All right, all right, all right. Let's see. Let's do a mic check. Okay, so I think, let's see. Let's do a mic check. Okay, mic check is fine. Okay, so it's fine. It's think, fine. Let's see. Let's do a mic check. Okay, mic check is fine. It's good to do a mic check recursively. A mic check on the mic check is good. That's the USS Reliant. Mutara Nebula. All right. So what I want to do, is I want to create separate apps. Like the fact that I have one app that is trying to do everything is too much. So really what I want to test is my particle class. So the particle class that I want to have a particle class, and I want to have separate apps that each test this particle class. And I want to see if I can get the data. Can I reproduce the data? Whatever the data is, any experiment of quantum entanglement, I want to be able to reproduce it. First, I need to know what the experiment is. And then I want to be able to reproduce it. My intuition is, as always was, that I should be able to reproduce any quantum entanglement experiment. There should be nothing strange, weird about quantum entanglement. That's my intuition. Now, historically, Einstein went to his grave thinking that he settled quantum entanglement in the EPR paper. Einstein wrote the EPR paper and no one responded. That was the end of it. And then after Einstein died, Bell wrote his paper. So Einstein never had a chance to respond to Bell's paper. My intuition is Einstein would have mopped the floor with Bell. That's my intuition. I don't understand Bell. I don't understand any of the explanations that I've been given. I've listened to many explanations of Bell's theorem. I've listened at this point to everyone about quantum entanglement. Brian Greene, I've just discovered lately, he is really amazing. I used to not like him, but lately I've discovered that he's incredible. So like this video, I don't think I finished. When is this video from? I don't know. They don't have the date of the video, so I watched this, I think the entire thing. I've watched a lot of content from Brian Greene, and he discusses quantum entanglement and Bell's theorem. I don't remember if I was paying attention during this. This experiment, I don't know. I don't know if this is really Bell's theorem. I don't know. I don't know. This is Sean Carroll. I've been listening to him for a while now. Really good stuff. Really great stuff. What else we got? Um, no, don't go there.
Imagine we have a
I didn't want to go there. No, I have to restart. Jesus Christ. What else did I watch? This was a very good video. I mean, a podcast. Really good stuff, especially about the ether. I think this was a good video too. Very long, right? No, not very long. Okay, some of them get very long. So this was a very long Q&A, 2.5 hours. This is good stuff. He did curvature, introduction to GR, really good stuff. I mean, this guy's a real expert in GR. I think Sean Carroll is also. I mean, these guys know their GR like really well. They can explain it so fast and go through the proof so fast. It's amazing. And this is Noether's theorem. I had to stop in the middle. I couldn't follow the Lagrangian. I don't think I was following it. He referenced something, so I stopped. Um, what else? Okay, so the point is that this is more quantum stuff. It's difficult to see, but I mean, each one of these is like an hour plus of quantum. Like there's short videos, but then long videos. Most of my time on YouTube is quantum. This is interesting. I don't think I finished this. I don't remember listening to too much. I don't think I listened to this. This is great. But again, I'm not really understanding it. I don't think I listened to the whole thing. I don't think so. Okay. Yeah, just more and more bell tests and bell stuff. Okay. Tim Maudlin is a lot of bell stuff. Another bell guy. Bell stuff. Bell stuff. Non-localities bell. All right. So, so let's go to this. Okay. So I want to create a bunch of notebooks, I guess. One of them, like, we're just gonna separate the apps. In all of them, we're gonna reuse. I don't know how to reuse like a class. I don't know how to tell it how to import. How would I export a class so that everyone would be sharing the same class? I don't know how to do that. Is there a simple way to share a class in a notebook without copy pasting? Let's see. How to share a class in Google collab between notebooks. Okay. Share Google Collab class based on create a new GitHub. No, I'm not gonna create a GitHub repository. Oh my god. Isn't it already? Isn't Google Collab already a GitHub repository in your Collab notebook? Import the class from the GitHub repository using import. You can use Git. I'm not doing that. Save your class in Python file your Google Drive. In your Collab notebook, import the class from the Google Drive file using import statement. Share the Google Drive file. Okay, this is a little confusing. Using Collab notebook link, create a new Collab notebook with the shared. Okay. Share the Collab notebook link with others, allowing them to open a copy of the notebook in their own Collab environment. In their Collab notebook, they can import the shared class using the import statement. Import with the link. And then, save and import shared class. This looks like the best way to do it, the simplest way. Nevertheless, let me see. This server. Yeah, this server is dead. Dead on arrival. It has died. Okay, so the first thing I want to do I think is create a new notebook. New notebook in Drive. And in this notebook, we're gonna have this class. Okay. This doesn't do anything. This is just the class. It doesn't run any code. So what I would try to do, let's see what they said. They said save link IPYNB and then import the class. So here they say instead of this, so remove this and paste this. Except for the link, that's not. And then the shared class name is particle. Okay, now run this. It's trying to do something. It's unable to import. Oh, why? Okay, it doesn't know how to import. So so in their example, there's an IP import the shared class using the import statement, but there's an IPYNB. Oh, there you go. This is the IPYNB. So let's just call this the particle. IPY. Wait, why don't you like that? So, but they have a link, content, drive, my drive, shared class. What is this link? Oh, it's maybe here. This guy. Copy link. Nah. Could not be resolved. All right, maybe this guy. The name is shared my drive shared class. Is this where I put it? Collab notebooks. Oh, copy link. Copy link to what? No. Okay. Copy this. Paste. And this is called particle, but this is inside collab notebooks. How do you copy the link? How do you copy these words? I guess rename. Collab notebooks. Oh, what? Content drive my drive collab notebooks. Maybe we need anyone with the link. No. Then I don't know. I mean, these two notebooks are right next to each other, so theoretically, I should be able to just say save particle. Not even that. I should just be able to say import particle. No, that doesn't make any sense. Right, both of these notebooks are in the same location. Okay, I don't know how to do this, and within with the shared class, share the collab notebook link with others, allowing them to open a copy of the notebook in their own collab. In their collab notebook, they can import the shared class using the import statement. But what is the meaning of this path? I don't know. I don't know. I'm worried about maybe that we need quotes. What? Why is it adding double quotes? What is going on? Who asked you for this quote? No. 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 Nothing. And the class is there. I mean, class particle is right here. Let's see if somebody on YouTube says how to import a class in Google Colab.
Hi everyone. In this brief tutorial, I'll show you how to import a Python script as a module within Google Colab. The first thing I'll do is I'll create the Python script that we'll use as a module. So I'm going to go to my Google Drive and create a new Google Colab file. And this script will just be a simple function. And what I'm going to do is I'm just going to take the square root of a given number and return it. We'll rename this as square root. And we can save this as a py file and download it. Next thing I'll do is I'll drag and drop our py file into Google Colab. And I'll go over two methods that we can import the file. The first method is we can connect to our Google Drive, so I already have this connected. We go to Drive, My Drive, then we go into the specific folder that contains the py file. So in this case, I am going to copy the path. And I am going to do...
What is copy path? I didn't see copy path in the Google Drive. There's no copy path. How did he do the when is this from? 3 years ago. It's probably outdated. It's over there. Let's try this again. This is in the Google Colab. I don't see a path. Copy link to cell. Okay, I don't know how. Well, I just don't
folder
have
that
it.
contains the py file. So in this case, I'm
This is the Google Collab files, and he has this thing. I don't have it. Maybe this thing? Sample data? What's this?